The objective today is to compare and contrast several file system types. So last time we talked about what file systems are and used some just general characteristics of file systems to compare and contrast, or at least build a basis so we can compare and contrast these file systems. Today we're going to just dive in and use some more specific details using certain file systems. As you can see from a chart like this, we have so many different types that we can compare and contrast, not only by metadata, as you saw the title right there, but we can use all kinds of things like limits, like maybe even general information to compare and contrast them. And that's sort of the beginning approach I'll take today, is we're going to use some general information, thinking about maybe the years that they existed. We'll use that kind of information to begin the comparison. So here you go, sort of a trick question. What is the world's first file system? And looking at this first row, the name of the operating system that ran this was a PDP-6 monitor. I tried to do some research to learn more, but I could not find very much on this monitor operating system. But so you know what a PDP-6 is, there's a picture of one. So we're talking back in the days when computers are really large and really expensive. So trick question, looks like DEC and IBM were creating file systems on operating systems on computers in the same time frame, 1964. And I found it interesting to go to this website to learn as much as I could about some of the first computers like the PDP-6. Let's zoom in a little here. It says the PDP-6 was effectively the first model of the PDP-10. They are mostly binary code compatible. And this website, gunkies.org, is just a great one to learn about some computer history here. Look at that. The form factor for this thing was called a small mainframe. Few hardware people would know about form factors. And in class, when we put a computer together, you were looking at a specific form factor for your motherboard. So a fun fact for you here, the machine was not a success. Commercially, there were only 23 of them sold, and in part this was because the hardware was unreliable. Let's switch gears here real quick and start thinking about baselines for modern day file systems and not go so into ancient history. A modern day example of a file system would be Ntfs. And a characteristic of this file system is it supports file sizes larger than 4 gigabytes. It's known to better manage available space than the FAT or FAT32 file system. And if you looked back in our history table here, oh, it's not on this one, it's on our big one. If you look on this one here, you see FAT 8-bit, so FAT, file allocation table file system. This was first on the scene in 1977. So the basic structure of that file system has been being used for quite a while, and Ntfs is an example of an alternative one. Both, I should mention, are usable by the Windows operating system. So because the Ntfs manages available space better, there is less fragmentation. If you remember in the introduction to file systems video, I showed you a picture of fragmentation. This can occur when a file system is saving the files in a non-contiguous way. To better utilize space, you want some sort of feature to make sure your files are not fragmented. Ntfs also comes with a number of security-related features, which include on-the-fly file encryption, which to me, a security-minded professor, loves security-minded features. So it says here, compared to Ntfs, the FAT file system takes up less space. Ntfs systems perform less write operations to the drive, which makes them faster and a better fit for small flash drives, and they are cross-platform compatible. Now, the biggest drawbacks of FAT and FAT32 are a partition size limit of 32 gigabytes and a file size limited to 2 gigabytes or 4 gigabytes respectively. So if I'm looking at a FAT32 file system, I am able to save a 4 gigabyte file on that thing. Ntfs is fancy, that's why I did the greater than sign here. It's a fancier file system because it'll allow larger files. So with that in mind, what are some pros and cons to a FAT or Ntfs file system? You have to do some inferring there. Now here is an example of an exFAT file system. It says a new file system predominantly used for flash drives is called exFAT. This stands for Extended File Allocation Table, and it is also known as FAT64. Like Ntfs, it supports files larger than 4 gigabytes, partitions larger than 32 gigabytes, and its file management avoids fragmentation. At the same time, it is fast and optimized for mobile personal storage and handling media files. So there's our flash drive file system. When you format a hard drive or a flash drive, you prepare it for its use as a storage medium by an operating system. During this process, a file system is set up and all information previously stored on the drive is removed. So if you've ever heard of this term, format a drive, it means to wipe it, to erase everything on it, and prepare it for a new type of file system. While FAT and FAT32 are recognized by almost all operating systems, formatting a drive with Ntfs used to be a way to make the device unusable outside of Windows. So what's the only operating system that supports Ntfs? And I'm wondering if you could think of a way to get around this. Students in my operating system class, and even networking, depending on what unit they're in, might be working with this concept that starts with a V, and that's the hint to the answer of a workaround. So back to our old school table here, there's a George II file system used on the George II operating system apparently. And our first version of Unix, though it's called version 6, Unix uses a V6FS. And why did I call it a first version of Unix? Because this was our first wide release of Unix outside of, the secrecy of Bell Labs. So many of you, especially if you're in my class, have been hearing about Linux for quite a while. But if you've heard me refer to Unix or ever seen the word Unix, which looks kind of like Linux, this moment right here in the lesson is the lead up to the birth of Linux. You see AT&T as a corporation. What they did is they licensed version 5 Unix to educational institutions only, but licensed version 6 were available to commercial users for the price tag of $20,000. This operating system Unix was the most widely used version of Unix until the 1980s, and this is when price tags that are high frustrate a man named Linus enough to create a new operating system, but build on the same kind of premises and the foundation of Unix. Usually when you buy a computer, it comes like pre-installed with some sort of operating system. So if we're talking about like Apple computers, you're going to have Mac OS. That just makes sense. A lot of PCs, Dell, you can buy computers with Windows already on it. But for a large segment of the techie community, there are Linux fans like myself. And with that in mind, the different companies and the different operating systems that exist, there are also different file systems. And on a single computer, you can have more than one if you wanted. And that was an aha moment for me. When I was downloading Linux operating systems, I kept noticing it had an extension of ISO. When I looked up the file extension ISO, I read that it's a disk image. The I is for image. You can use disk images to house additional file systems with the same attributes or not within another file system as a file. So to step back in this inception-like example, we have a file that is acting like an entire file system. And this is what virtualization is. That's the aha moment. When I had a virtualized environment and I was using my Windows computer to have another operating system going, that operating system was stored and saved on the hard disk as a file, a ISO file. And this is where some fun stuff can happen. You can run experimental distributions of whatever operating system you want, even outside of the realms of just the Linux distributions. And then you can furthermore experiment with different file systems on those virtual operating systems. Now, by default, most Linux distributions are using what's called ext4 as a file system. And after a lesson like this, if you really want to get your compare and contrast skills at a high level, go ahead and install several different types of file systems and experiment with them using a virtual environment. And when I was researching information on the Unix 6 system, I found this really cool picture that I thought I'd share with you. In the last video, I shared what seems to be the world's largest single file, and I showed that to you via a terminal window. So here's another terminal window for you, but this is one from a Unix 6 system, and what it's doing is it's listing out all the contents of the folder source, which is inside another folder or a directory named user. So in dumping out the contents there, you can see all kinds of interesting files that allow the system to run properly. Okay, so to focus here, let me do two more as quickly as possible. A FAT 8-bit file system, and then what's called a DOS 3.x file system. And the X means there are a couple of versions of this particular file system that I'll go ahead and compare using just some generalities. Basically, the first version of the FAT file system was an 8-bit one, and it was designed and coded by a man named Mark McDonald. He is technically the first Microsoft employee, and he invented this based on a series of discussions he had with Bill Gates. Bill Gates being the man responsible for the Microsoft operating system. Some information on the side panel here for you. The FAT 8-bit limited files to 8 megabytes. I'll let you dive in deeper into granularity if you're interested, but another limitation to this file system was a file name length. For your run-of-the-mill text files, you could only use 9 characters. So we're looking at, like, if I had created a file for my lesson plans, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I couldn't call it lesson plan with a space because that's too many characters. So wow, FAT 8-bit file systems, those are pretty limited. What year are we looking at? 1977. In terms of what was allowed in the file name, we could use ASCII characters. And when I saved a file, was the date of the save recorded? No, it was not. So now let's go to our DOS, and I was thinking MS-DOS, which is a Microsoft thing, but this is an Apple thing. Apple DOS is the family of disk operating systems for the Apple II series of microcomputers, which microcomputer just means computer, so don't get freaked out over that. And this was from 1978 to 1983. And prior to the release of Apple DOS 3.1, Apple users had to rely, get this, on audio cassette tapes for data storage and retrieval. That is mind-blowing to me. So they didn't have like a hard disk, they had these cassette tapes. So here's some pictures for you of a computer, which looks like a keyboard connected to a television screen. Talking the 70s here. So here's our external drive, essentially. If I had a game I wanted to play, I would put the cassette tape into this and type on the keyboard, probably a command line terminal, directing the cassette to play and show that on the screen. And look at this one, it has a cassette built into it. Couple more pictures for you. Like, the Apple II was a very famous and popular computer. Looks like we could put this cassette tape in a few different places. So Apple's not the only company. Tandy, or what is the name of the TRS company that built these? But they had one as well. And then soon, I wonder how many students in my class have even seen data storage like this. This is a giant floppy disk right there. So in terms of the Apple DOS system, I just couldn't find a lot of details. I did find 4 file types that existed though. Apparently they were identified by letters in a catalog listing like this. You have your integer files. This was stored in a compact format, so not a plain text format. You have A files, which is AppleSoft basic programs, and they were also stored in a packed, like space-saving format. Compression, anyone? You got your binary files. These were either executable machine language programs or data files. It's confusing to me. And last but not least, just straight up ASCII text files. So a lot of you are used to some plain text stuff. So that's the end of the lesson. I gave you a few file systems to study, to do a compare and contrast to. So here's a chart I'd like you to go ahead and fill out. And I want to give you a lot of freedom here. So fill this out however you see fit. Make sure you pause right here if you want your creativity taken away from you, because I'm going to go ahead and show you an example here in one moment. So one last time, go ahead and pause if you want to just be creative. And now go ahead and push play to see my example. I was thinking of comparing and contrasting file systems by old and new. So here's some old ones that I talked about. Here's some new ones that I mentioned. Now, FAT is both an old name and a new name. The old ones were obviously very limited in size, like we discussed. New ones can hold huge files. For your average user, I don't think they need anything greater than 4 gigabytes. Even you gamers out there are downloading these games, downloading these folders where every file is not likely to be larger than 4 gigabytes. The files obviously work together to make the game work, but that'd be an interesting side project for you to do, is find out the average size of files in some of the games that you like to play. I mentioned a price earlier, so the old computers were very expensive, so maybe that's not so, file system related, but to have systems that hold as much as they do nowadays, it's even cheaper than just straight up dollars compared to the storage capacity. It's extremely cheap nowadays. We've always seemed to have read, write, and execute permissions on file systems. And the word format still means the same thing it did back then as it does today, that you would erase something and then you could determine what type of file system would be used on that particular storage medium. You could have filled this chart out in another way. Maybe you could have used like flash media versus hard disks or even SSDs. I mean, you could have gone into so many different directions. However you fill this chart out, though, I'm excited to see what you came up with.